Welcome to another episode of BTech. Today we're going to have a little fun and find out how much current or how much power all these Apple HomeKit compatible smart plugs can take. So how are we going to do that? Let's talk about our setup. So our input power is coming through this industrial GFCI. This is connected to a high current circuit in my house, which is not being used for anything else right now besides this test. It all comes in through 10 gauge copper wire, comes in through here. And typically you wouldn't use these standard NEMA 515R plugs. Usually these are only rated to 15 amps. We're going to be going above 15 amps today. But for these purposes, because these are all the standard US outlet, I have adapted here to these. So after that, you can see that I have a current measuring device. So the way we have this set up here is I use my current clamp and I use this inline adapter whenever I'm measuring current in circuits, because it exposes all the wires. If you clamp this around the full cable, the input and output current are going to cancel each other out. There's going to be no magnetic field for this thing to pick up on. So what I do here is I split out the wires. Blue here is neutral, green's just the ground, and then the black here is the hot. The reason I'm running two wires for each is because these are 14 gauge stranded copper, and they would do fine if I just had a single going up to 30 amps for a brief period of time. But they do start heating up, so just to keep this test more about the plugs and less about my test rig, doubled up on two 14 gauges here. Finally, our output, we go back into 10 gauge wire, and that splits off to these three 1500 watt heaters. They have a low and a high mode, and the low mode's about 6 amps, the high mode's a little under 12 amps. Simple resistive heaters. They don't have any sensors to cut them in or out besides a fall sensor, so they'll keep running. And by turning them to low and high mode in different combinations, we will have a sort of stepwise variability in how much current we can pump through the system. So what we're going to do is we're going to go in units of about 6 amps, which is just limited by the accuracy of those heaters. And then each minute that one of these plugs withstands that current load, we're going to go up to the next level, all the way up to a little over 30 amps. And we'll do a test run first without any of the plugs in there to show you how it works. And if they survive all the way up to that point, we'll take some final measurements of temperature, which we'll be doing along the way using this infrared temperature gauge to see if these things are safe at their indicated currents, that is, they're not heating up. And then just for fun, seeing what the maximum they'll withstand is. So who are our contestants? So our contestants here are lined up in order of cheapest to most expensive, which is not necessarily their indicated rating. So the first one we have is this Morose plug, smart kit, Apple HomeKit compatible. As you can see here, it's rated to 15 amps, which makes sense because these connectors that it has on there are typically rated to 15 amps. So first we'll put it up to around that, which for us will be a little under 15 amps and then a little over, to see if this thing's getting hot and to see if to see which current it eventually melts down at, if it does. We have the outdoor version, and the outdoor version we have only really being rated to 10 amps. And I imagine that's because it's got two plugs, so maybe the entire thing can take 20 amps. It doesn't clearly indicate, as far as I can tell. We're only going to be using one of the plugs, so we'll see how well it does with one plug. And then we have the Philips smart plug. All these are Apple HomeKit compatible. It says 1800 watts max right on there. And then it says here max 15 amps. So it's 800 watt resistive load. We have a resistive load using those heaters. Now this is a bit of an unfair test, but I'm just curious. These in-wall dimmers by Lutron Caseta, I use a bunch of them. I only use them for low power LED lamps, but I'm kind of curious how well they hold up. They don't even have a ground plug on them. And on the back, it tells me that, I basically can't go above 100 to 300 watts, which is like 2.5 amps. So this thing shall surely die today, but I am interested to see how high of power we can push through it, how much current we can push through it. Now this thing is by far the most expensive. These are over $80 for a single plug. They work incredibly well though. I have 2 of these going in my outdoor system right now. As you can see, they have a nice IP65 enclosure rating, a fairly large operating temperature range, and but they have these 15 amp plugs on them, which means they're only ever going to really have a rating of up to 15 amps. I'm wondering if this thing can actually take a lot more than that, and maybe more than I can provide for it today. So we'll see what happens. I'm curious. All right, without further ado, we'll get to testing and hopefully learn something today. All right, so for the first run here, we're not really going to be doing a test. What I'm going to be doing is just turning on my current clamp here, making sure that we can read it in the video. Yep, we can. There's a little bit of a glare here, so I want to do my best to keep the glare from interfering so y'all can keep seeing that. And then I'm going to do the timer for the future tests. Right now, though, all we're going to do is to just show you how the system ramps up with power. So I'll get the whole system energized, and then we'll get to testing. All right, the system's energized, so I'm going to just reset the GFCI. So we have power flowing through our system now, and we're going to start turning on the heaters. So the first heater is being set to low. As you can see, we're right about 6 amps there. Now we're going to set it to high. We're up at 11.5 amps. So we're moving in very roughly units of 6 amps. Next heater to low. We're up to 17.4. This heater to high. We're up to about 23 amps. Next heater to low. 28 amps. Next heater to high. 33 amps. Now feel these wires. It's only been energized for a moment, so wires still feel nice and cool. Just as a baseline reading here, it's pretty cool in here right now, about 55 degrees Fahrenheit. All right, let's shut these down. All right, for our first test, what we're going to do is put the morose in line here. Now, morose is again rated to 15 amps, and there is a button on the side here, which is controlling the on-off manually and also resetting this thing for the Wi-Fi. What I've done previous testing with these, it seems like the relay is on this side, so most likely this is what power is going to be flowing, and it's going to be hottest. So what we'll do is we'll scan around to find the hottest part as we're going through this, and use that as our measurement. We'll do that for all of these. We'll really try to take the temperature measurements at the hottest part. That's going to be the weak part. All right, let's start the test. So this thing smells like smoke and is blew out. It's no longer functioning. Looks like we got up to around 250 some degrees. I'll have to check the log there. You can see right where the hot spot on the relay is. It's just milled it straight through there. Maybe once it cool down, we can take a look what's inside. Pretty impressive, you know, it made it pretty long at about 28 amps before burning up. I think the dangerous thing about these things are that they don't keep you from running it. There's nothing that sort of detects high current and blows out early like a fuse or a breaker in there or anything. So it looks like it is possible that this thing could at some point light on fire, although we didn't see that. Luckily when it burned out, it just ceased functioning. All right, for our next test, we're going to be testing the Morose Outdoor, which is rated for 10 amps, but I suspect they mean 10 amps per plug. So we'll see if it gets a hot spot and how much current it tolerates. Baseline temperature here. I don't know if this where the hot spot is on this one, so kind of scan all around. There's our baseline. All right, so this one is dead. Very hot, smell of burning. All right, next up will be the Philips smart plug. Again, this is rated 15 amps, it's 1800 watts max on it. So let's see how well it does. Let's take some baseline readings. 57, 64, get my hand in there. But... Okay. So with the Philips plug, it's warm to the touch, but even after 15 minutes, there's no discoloration, there's no burn through. It's just, yeah, really, it's still working just fine, and there's nothing here that feels dangerously hot. All right, so what we have here is we have the Lutron cassette dimmer back in place. I have my variable speed drill, which starts at right about 2.5 amps, which would be perfect for testing this. I just have to hold there at 2.5 amps. So maybe a little tricky to get the temperature measurements, but we'll do our best. All right, so we're going here right at around 2 amps, which is under this thing's rating. So let's see how well we can keep this going. All right, so we were surviving up at 4 amps pretty well, so let's try 6 amps on the heater. Surprisingly, it's actually working. But it looks like we're going to be heating up pretty quickly. All right, let's see if it'll do 12 amps. Surprisingly, it is. So we got pretty dang hot there, as you can see. 189 degrees. The highest temperature I'm seeing. All that heat's really right here. No signs of damage though, which is good. I'm glad it failed before you could see any real problems with it. I don't smell anything, any plastic burning or anything like that either. It's already cooling down. Did get hot to the touch, but nothing to write home about. Pretty surprised how this thing actually held 12 amps for a little bit, being it's, 5 times what it's rated for. Pretty amazing. All right, on to our last contestant. This feels very heavy duty. It's very expensive, but it's only rated for 15 amps. I remember the Morosa is rated for 15 amps. The Philips is rated for 15 amps, but they performed very differently in our test. Let's see how we do here. Essentially no heating at all. Still cool to the touch all around. maxed out at about 158 degrees there. So as you can see by this plot, the total amount of charge that went in during the test, which we have on the bottom horizontal axis, versus the temperature in degrees Fahrenheit on the vertical axis. And you can see that the different plugs had different trajectories. So a steeper slope here, like the Lutron dimmer, which is the most steep, shows that it heated up very rapidly with very little charge, which makes sense because it's only made to handle a few amps, in comparison to the Philips, which did the best, which had the least heating over the entire test and had the lowest temperature at the end of the test and never broke the entire time. The Lutron Outdoor also never broke, but did get a little bit hotter than the Philips. The Morose Outdoor was a decent, not too steep of a heating curve, but it did die before completing the test. And then the Morose Indoor, although it didn't break until near the end of the test, it did break, and you can see that it heated up a lot there compared to the other plugs that are rated for 15 amps. Here is a final report for all the testing that we've done with the Apple Homekit compatible smart plugs. As you can see, in the price category, nothing beats the Morose Indoor, as they're still going for only $10 a piece in comparison to the $8 a piece Lutron Outdoor. However, you may be getting what you pay for. The connection reliability for the Morose plugs I found to be extremely poor, with multiple disconnections per week, requiring power cycling. That being said, with only one running in my house at the moment, it's actually had quite reliable connectivity. So this is probably only the case if you tried to use multiple plugs. However, the Philips and Lutron plugs, they all have perfect connectivity regardless of how many devices that I have on my hub so far. However, the Morose plugs do not need hubs, while the Philips and Lutron plugs do need a hub, which needs to be considered. Now, if you are going to go put stuff outdoor, the Lutron Outdoor was the only one that had actual IP65 rating, which is why it's the only one I highlighted green. However, the Morose Outdoor did seem to be at least marketed as an outdoor plug. If you need something that's dimmable, it won't handle very much power, but the Lutron dimmer is really the only one available. But it works great if you're using it for just dimming some lights, and you'll never get close to exceeding its power rating. If for some reason you do think that the circuit you have these on may get high or even exceed the limits, which I clearly don't recommend, but for some reason, if that is important to you, the Morose Outdoor and the Philips both reached the lowest temperatures. In the case of the Morose Outdoor, it failed at 121 degrees. In the case of the Philips, it was only at 122 degrees at the end of the testing. But the Morose Outdoor did fail. So who survived the power test? Only the Philips and the Lutron Outdoor survived the power testing. So if you are going to be using something that is more power hungry, this might be something that you want to take into consideration. Overall, for me, with the connectivity reliability and the good power testing results, I use a combination of the Philips, the Lutron dimmer, and the Lutron Outdoor. I'll use the Lutron dimmer for LED lamps wherever I need to have something can dim. Use the Lutron Outdoor for outdoor light purposes, and the Philips for all of my indoor purposes that I just need a binary on and off. Hope these videos have been helpful for folks, and they help you in selecting your appropriate Apple HomeKit compatible smart plugs. Until next time.